Okay, so welcome everyone, or I guess the few of you that we have here. So before we dive into what we're doing today, how was the Three.js project? Hard?
It wasn't bad actually, I think.
It wasn't bad? Okay, I like that.
I don't know, I took a lot of time.
It took a lot of time? What did you guys find the most difficult?
What is JavaScript?
What is JavaScript? That is totally fair criticism. So I actually got a lot of messages on Slack and from people asking me, saying that the homework was hard and this is the first project, maybe you guys don't know what to expect. So even if you turned it in or if you made a GitHub release, you can turn in, everyone in the class can turn in until Thursday without penalty. So the late deadline was usually Thursday, but since so many people seem to be having problems with it, and I don't think it's fair to give half the class an extension, so all of you guys can turn until Thursday, 1:30 p.m., as if it were late, but I won't dock the 25%. Do keep in mind, though, that so this is the first assignment. I'm happy to be lenient, and my policy on extensions that I posted on Slack will extend to the future assignments. I just really want to ask, please start early on the one that we're going to talk about today, because if you thought this was hard, it's going to be a lot harder.
Is it also Three.js?
No, this will be in Unreal, and unlike Three.js, well, I should say this the other way around. Three.js, unlike Unreal, doesn't crash, doesn't run on your computer, and isn't a memory hog, a battery hog, and performance drain. So Three.js is one little 50K JavaScript library, right? You're going to be running a 15 gigabyte application consistently, and that's going to lead to problems. So just wanted to leave that out there. But yeah, so good news is you have until Thursday if you want to improve your Three.js at all. People have been asking me what the grading is going to be or how that's going to be done. So the general thing, the general rule there is if you've done the minimum requirement, you'll probably get somewhere in the A- range because you're going to be curved against whoever else is doing it, and that's our only metric for saying how good something is. And if you really want to exceed and go above and beyond and make it look get a really good grade and really show off, the better you make it look and the better you make it feel in VR will be key there. So if you have fireworks that have particles that are indistinguishable from the sky because they're so small, that's something you can improve for. Anyway, that's just some notes there. So before I pass over to Trung today, does anybody have any questions on the Three.js project? Anything you guys want to talk about? Kelly?
So you mentioned releasing it on GitHub.
Yeah.
Is that different than making
Yeah, so the way you do a release, and this is not purely necessary, but it's easier so that you can see what the state of the repo was at the time and so that it's easier for us to see. So I just picked a random project. If I go to releases, it says there are no releases. So if you click this and you own it, you can make a release and it'll bundle the source code at the time of whatever you made this release at. So instead of us having to go through your commits and say okay, this one was before the deadline, or if you do stuff after. Also for your own sake, when we get to the next project, there's going to be alpha, beta, final, so you're going to have to do releases for alpha and beta. But yeah, that's I won't penalize you if you don't do that, but it's just nice. Anything else? Okay. So without further ado, I will abdicate the stage to Trung, who's going to go full in-depth into Unreal Engine.
Well, so first, dev is really deep. Okay, so do you guys all have your laptop out? I'll give you guys a couple seconds as some people just got here. And just go to Unreal Engine. It's gonna take a minute to load. Okay, so just really quick I just want to describe what I want to do today. I'm just going to walk through basically develop just simple logics inside Unreal, how the home blueprint system works, and we're going to try to make a simple game. So let's show the budget cut thing again. So I'm going to do something similar to what budget cut did. License has expired.
Is it for Practicum?
Oh no, for Unreal Editor.
Yeah, that's hold on. That's Practicum. Let me go kill the.
Oh, can you do?
Yeah. If you want to talk about budget quick one of these.
So in Bushing Code, I showed that we have this like shooting something at a point, and then you can teleport to that position. So we're gonna try to go through and replicate that mechanics today, and I'll just show you guys how you can do it in Blueprint. It's actually really simple. We're not gonna do the whole like teleport, like preview the scene and then teleport in. We're just gonna like shoot at a point, and if it's the ground, let's go to that location. And then we're gonna make like a simple level game so that the characters can like move around again and stuff like that, using that mechanics.
What? So I can't delete this. Oh, the engine is open. That's why. Sorry.
Oh, okay.
Give me a second. Okay, so sorry for the delay here. I had a plugin installed for Pen Apps that the license expired because I didn't buy it. So that's what happened.
Okay. So you can use whichever Unreal project version that on your machine. I'm using 4.14 right now. For Mac, I recommend using 4.13 if you see a lot of crashes. For Windows, it's okay with 4.14. If you don't have that installed right now, don't worry about it because it takes a long time to install a different version.
Also, if you can avoid doing this on Mac, I highly advise you do that, whether that means you just work in the lab all the time. It's really unstable on Mac.
How do you do the magnifying glass thing that you do?
Then Control plus and minus.
Oh, Control plus.
Yeah.
Yeah, awesome. Okay, so are you guys here all in your project? We're just gonna go. Okay, so these are all Unreal templates. They have like base mechanics. So we're gonna start with a template from first person, and make sure you choose Blueprint here instead of C++. We're just gonna use the Blueprint instead of base code. Down here, make sure you have restored content on. So this gives you some basic measures and basic like visual effects and materials and stuff like that, so you can play with. Name the project however you want. I'm just gonna do like VR tele game or something like that.
Real quick, who is following along on their computers, just so we know?
Yeah.
So at least a couple of you.
Anyone needs 10?
Yeah, if you guys need a couple minutes to like it.
What is just like first person?
First person, yeah.
Is there a way to make it not measure as high quality?
Yeah, we'll show you. Well, you can change it here or you can change it when it's open, either way.
Yeah.
Also, as an addendum to, we mentioned this at the end of last lecture, but I didn't fully explain it. I think it's worth talking about. When you asked, why is my computer like spinning like crazy when I just have like this scene paused and open, you want to know why? Because the editor that has like the world that you can navigate just runs the game paused.
It just runs the game with the time step equals to 0.
Yeah, it's like running the game with no time. So you're essentially running the game whenever you have the engine open. Yeah.
Okay. Well, I'm gonna create the new first person project.
I forgot about the Akinama thing. Sorry.
It's okay. Is it making?
Did it open? Is it that one?
Load.
Did it load 2 of them?
It's fine. Okay. At any time, if some of the stuff on the screen is too small, let me know, and I'll try to zoom it in. But Sasha talked about the anatomy of the editor a little bit before. I'm just gonna refresh it a little bit. So on this side, on this panel on the left side, these are all the different basic objects you can put into the game. So you can put like a cube and stuff like that inside the game. This side on the right is the outliner. So every time it show you basically the all the different objects inside your game right now. The top level is the map that you're working with. So each level inside Unreal is contained inside a map. And all the geometry and stuff like that's inside it. And then every time you click on an object, it opens like an inspector mode where you can see the transformation of the geometry, and then what kind of mesh it's using, what kind of material it's using, whether it's using physics or not, and stuff like that, so on and so forth. The content browser is on the assets, on the asset that you have. So it will contain, if you go to the content browser, they have the starter content. So because we added it in the beginning, in starter content, these are all the stuff you guys can use for free. So that, for example, you go to materials and you can see a lot of basic material that you can use. You can like put over, and then now you have like a new material for your graph. So go to content on here on the top level, kind of like the directory, and then you can see a content here, starter content here. They have some basic maps, which is different levels that you like sample. Like I'm using one the example level right now, so I'm using the what is called a minimal default level. It's a default level they have, and then materials you can So what I did was go into material, and then if you click on any material right here, you can drag and drop into any surface and change it to material of the scene. So you can use any of this stuff for free.
So real quick before Trung goes
Yeah.
on, who knows how it knows, like when Trung clicks a material and drops it in the editor, who can tell me how it's like finding out which object you want to put that material on? This is stuff, what'd you say? Raycaster. Boom. You guys
Yeah.
remember from 3JS, right? Like if you shoot a ray from the camera and turn it into world space, that's what it's doing.
Yeah, I figure what's the first object that it intersect with. That's the object that we get the material, and then you click on that object. Let's say I click on the floor, and then you can go to, you see on the inspector, on the detail, the material has been updated to what material you have. So it's automatically reference everything. I recommend if you need to delete stuff or edit stuff, do it all inside the editor. You know, like if you delete a file, don't do it outside in the default directory. Just do it all inside here.
If you guys mess with stuff in File Explorer or Finder, it'll not behave well with Finder.
Yeah, because they have like references to all each other. Okay, so very similar to Maya. To move objects around, you click on the object. So you have the default transformation. Each of the arrow, can you move left, right? In Unreal, it's different from other editor. Z is up, not Y.
That's really important because if you start translating things, they're like, why is it not going up? Z is up.
This is up. Just so you keep that in mind. It's unconventional compared to other game engine and stuff like that. So okay, so if you hit the key W, that is for translation. If you hit E, it turns into a rotation gizmo, and you hit R, it turns into scaling. So WER.
So if you have the object selected and you're in the editor and you press W, E, or R, it'll change the transformation that you're editing.
So you see on the top of the editor, they also have that here too. These are all the hotkey that help to like level designing. So W for translate, E for rotation, and R for scaling. Yeah, so these are all very basic stuff. Okay.
Is everyone here? Just real quick status check. If you're following along in the game, or you guys have the scene open?
How do you zoom out of the screen? Right now, this is stuck in
What do you mean zoom out the scene?
there. Oh,
Mouse wheel.
go out.
Yeah.
You just go.
Yeah.
Yeah. Just move. You can right click, and then it does this like sort of tumble around, and then you. If you guys have mouse, it's actually, I guess it's a lot easier.
Yeah. If you're on a trackpad, good luck for this part.
You can hold also. I guess you can left mouse also works too. Yeah. If you want to focus on something, so let's say I want to use so far away, and then you select an object on the side. Like let's say I select an object editor cube 21. I want to focus on it. You can hit F, and that just automatically focus on the object too. So in case you don't have a mouse, maybe that helps to like focus on whichever geometry you're working with. Okay.
Also, most of the stuff we're going to be doing today is not going to be relying on like mouse geometry movement. So just be aware.
Yeah. So okay. So you can test play it. Make sure you can have audio on, but it's gonna make sound, by the way. So you can turn it off.
Well,
So,
hold on,
oh,
go
sorry, yeah. There's a play button on the top. Then you just hit play, and it will just play. Oh, how do you turn this thing up? Okay, it's too loud.
Wait, but we like our sound. We have a sound system.
Yeah. Oh, you can actually, instead of muting the system, so enable, yeah.
I just need the system.
Yeah, I'm just gonna mute the sound, by the way, because yeah. Okay, so yeah, you can run around, you can jump up, and then it's shooting some basic gun and stuff like that. And this is like not accurate bullets because they kind of just curve down. But this is actually really convenient for us because if we want to do what Budget Cut did, let me show you guys the video again. So, like what they did in the game with the teleportation, where is it? Yeah, so they shoot some sort of gun and it goes in a curve like that. We're gonna borrow what Unreal already had at this for this gun shooting. And then every time the bullet lands or something, that is the ground, we're gonna teleport to it. So that's the goal of what we're trying to do. Okay. So let's go up. Let's go back to the content browser. Okay. The play. Escape. Yeah. Sorry. Yeah. You hit escape and you can quit out of the play mode and stuff like that. Okay. So I'm going to walk through the outline really quick so we kind of know how the structure works. It's kind of work like a file directory. These a folder. If you guys can read the text, yeah. It's just basically they have a folder that contains all the geometries and static mesh actor. The name actor here is the basic object in Unreal on the high level. So Unreal is the lowest level. The object is called a new object. You guys probably will not have to touch this a whole lot. This is like very low level. And then everything else in Unreal is derived from new objects. And almost all the objects that you can see in the game is called an actor. So what you see here, the big wall, is a static mesh actor. So it's a mesh that is not changing, that's not deforming or anything like that. It's static and it's an actor type. So they just they just put a bunch of stuff inside of the arena, have a bunch of random cube and stuff like that.
You guys will note that this is also a scene graph. So if you parent things, it will act like any scene graph you've seen will.
Yeah, this is kind of like a scene graph. This is also an actor, but it's of a light source type. So it's called directional light, so that's why you see the sky over here. Ignore on this light, mass, important volume, post-process volume. These just to make the scene like kind of pretty with the fog and stuff like that. Skylight is another thing. Just so they use two light. They use directional light and then another overall skylight in the scene. We don't worry about atmospheric fog or reflection capture. This is a trick to do like reflection. Okay, so first-person character. This is the actor that we've been controlling when we start the game. It's called a first-person character. Network player start. Unreal. I don't know how to describe the player start.
I can talk about player start. So like, basically the way, if you've ever thought of a game where there's more than one person playing, right? One person has to like host and another person will join. So the same way you have like a listen and a server socket versus like a client socket. So a network player start basically says, when you're hosting a game and someone else joins, make them start at this point. So that's all that means.
Yeah, it's just basically a location. So you double click it, so have location. Yeah, you don't have to worry about it right now. But every game has some sort of player start location of a player start type. The sky field blueprint is just, if you look at this, it's basically a giant sphere, but that's what the sky is. So if you double click on the sky blueprint, it zooms super out. So that's what you see. So yeah, everything you look over here, just basically looking around a giant sphere. Template label, we actually don't need this. This is just like a text that they have to show like the first person template. It's just a text in the screen. I'm just going to delete this.
Function view.
How do you like going back from the different style view? Like, how are you going to take the
Oh, I double click on any object inside the scene. So yeah, so it's just, if you double click on it, it's just focus on the object.
Or
so,
single click and press F, either way.
yeah, also works. I'm just gonna delete this template. You don't have to do it. It's kind of bothered me a little bit. Okay, so so that is every single object inside a scene. Okay, so what we're gonna be doing with today is edit the first person character so that we're actually not editing it, but I'm gonna go dive into the first person character a little bit to explain how the blueprint of the first person character works. This is a template that the first person game, when we selected to create a new project, is create this. It's called a blueprint for first person character. So if you click on edit first person, it should open a new window that has that is a blueprint window. Are you guys on there?
I'm not at the same place.
Okay, so first person character.
So, right there.
Yeah, so click on it, and then are you just running on your phone?
Yeah.
Whoa.
Oh.
That's some
I'm
next.
not into the party.
That's like some next level meta right there.
Wow, it's gonna be a little bit hard to edit, but anyway, so you're inside a blueprint. So blueprint is just a visual language that Unreal has. It's pretty unique to Unreal. It's all node-based. Sasha mentioned this a little bit before. Every node is kind of like either a function or an object. So every node that has like this symbol right here, they call exact or something. All these nodes are functions or events. Okay, so F stands for function. If you see a node that has F, that stands for function. You see a node that has this red thing, and you hover on it, it says it's an event. So it just function event. Just basically those are like different concepts of in Blueprint. So there's a lot of stuff going on over here. We're gonna ignore a lot of this stuff. So they have like if Asian emotion controller will use VR gun. So this template will work out the box for a VR game. Also, they have like a VR mode enable, but we're not gonna go into it today. So we can touch on this later. But I'm just gonna ignore every group that say VR stuff right now. Okay, so how does the character move? There's an event that called the input axis move forward or something like that. Every of these events that basically take from the control from the keyboard or something, and then this event trigger a function add movement input. Basically, it takes in some direction, some value, and then it will just push the character in that direction. So this is a simple get an event, create a function that handle it, and all these stuff that it takes in right here. These are all just parameter, like they are either if you hover on it, it's to say this is a camera, so it moves from the camera, get the forward vector, get the actor, which is like where your character is. So an actor is just like the object where your character is. When I say actor inside a blueprint, that refers to the whole object. And then it does stuff right here. So
that select is doing something a little bit tricky. If you zoom in on the top one real quick, just a little bit. Right there. So if you look what this is doing, who thinks I can tell me what this node is doing for those two values? So it takes in, what does it take as input? Can you scroll left a little bit? Sorry, who said something? Is that, okay, so those aren't booleans, but it does take in two things. What are these connected to? What are that, like, this is get forward vector and get forward vector, right? So those two are vectors, also known as yellow means vector. But, and then it takes in this third thing. So like this third thing is red, so it's a boolean. But based upon what we've seen right here, so it takes in these two vectors, false and true, and a boolean. So what do you think it outputs? Is that in the back? Exactly. So if the boolean is false, you take that vector. If it's true, you take this vector and you pop it back up. It's like a switch statement.
Yeah, or mutex.
Or yeah.
Yeah, that's like a basic, yeah. So the common stuff right here. So wherever you see this white stuff, I recommend working in team, doing what they do here. Every group of node like this, you can put a comment. I'll show you guys how to do comment in a little bit. This is the same. So they have you from the headset display movement, and they also have like using a stick controller, like if you have expert controller, and then this thing using a mouse input. So the mouse allows you to, yaw pitches is basically how it orient up, left, right for the characters, for the camera. Jump, yeah. So if there's an event called jump, then it will start jumping. And spawn projectile. So this is kind of the stuff that we're gonna go through. So spawn projectile is like at the bottom of the blueprint node. So you go down to here. Okay. So don't worry about where the action fire event comes from. But basically the idea is if you press the, well, you guys see it, you press the left trigger, then it's fire this event. I wonder if is there an easy way to show like the flow, like debug flow, you know?
Yeah, if you put a breakpoint on the function and then put it on the blue one.
Okay. Okay, so yeah, so you see this event is pressed. When the key is pressed, it goes over here, and it starts montage play. This plays the animation of just the shooting for the arm. So you can right click on it, put a what is add breakpoint. Yeah, so you can put a breakpoint there. Yeah, I'm gonna undo the zoom thing. Do I have to turn on simulation?
No.
Yeah. Play from here.
Yeah. So if he hits play,
and then
shoots something,
it's pause again, and then you see right here that the event just fire, and now it's stopping right here.
So this is like okay, how much better than GDB is this? If you remember, like any kind of debugger, like you can see where the path is. If Sean hovers over these inputs to the function, it'll tell you what the values are. So like current value is first person at MVP.
Yeah.
That thing.
Yeah.
This is a bad example because there's no
There's no.
I mean, here there's only one, but like this debugger is amazing, and you can see the value of anything at any point in time.
Yeah.
So he put a breakpoint via right-clicking a function node and then add breakpoint and then just play.
Right. So yeah. So I'm gonna.
How would you exit it to go to that?
Just Alt-Tab for the window.
Yeah. So yeah, once you put a breakpoint, you just hit play from it, and then when you fire something, it pauses right there. So you see it, nothing has finished rendering yet. So it also tells you that it does the logic before it renders. Also, but just like the minor details. Yeah, and then I think you can resume, or you can go to the next frame. So frame skip, just step you to the next one.
So one thing to note, I guess that's super relevant here is, can you unzoom real quick? The frame skip button up there isn't like proceed to next instruction. That in the renderer will say debug on next frame. So there could be a lot of other stuff happening that will not, like this may not be the next instruction that it runs.
Yeah, it's just the next frame inside this blueprint thing. But there's like a lot of other stuff go between, like it has to render, compute other stuff. It can be multi-threading.
So it's not a direct correlation to step like you would see in a normal debugger, but it's similar.
Yeah, it's just basically step to the next. So go the flow execution, just flow to the next one. Yeah, and then it's just basically debugging. So I'm just gonna resume it and go back. Okay, so it took me somewhere crazy, but I'm still in the same blueprint called first person. No, it's I'm in a different blueprint now called first person projectile. So I'm just gonna go back to where I was, first person character, because sometimes you debug and it takes you to like some places. Well, okay, so that is the flow. So what you see here is when the event is fired, I'm gonna turn off this remove this breakpoint. When the action gets fired, play some animation. I'm gonna ignore the animation stuff. We're not worried about too much. And it flows to the next one. This is the one that we care about. Spawn actor, first person projectile. So it's a node that spawn a new actor, and then it takes in a class called the first. I don't know if you can see it. It takes in a class called the first person projectile. So basically, every time you fire, it spawns a new bullet called projectile. And like a sound at the location. So that's why you hear the bang sound. If you don't like the sound, like I do not, you can right click and break link, or you can alt click. If you alt click on a link, it just break it. So now it would not play any sound. It would just go here and it stop. Okay, so spawn first person projectile. It has some transformation. Meaning it has some like the initial location or orientation and scaling where I start with. So our idea is when a bullet travels and hit something, we're not worried about the ground yet. If we hit something, we need to teleport there. Therefore, what do you think is the easiest like solution, or like what's a good approach to do that?
Like the projectile, you have the final position usually, so like you just take that outside later and take it back to the person.
Yeah.
And then like keep that in place.
So what's that final position? So it collides with something.
Oh, right.
But
So
yeah,
like
when it intersects with something. Yeah. Okay. Yeah. So maybe it makes more sense to do all this logic inside a projectile. Just for the simplicity. There's multiple ways you can do this teleportation. This is one way to do it, but I'm going to do it the easy way, which is the way you just suggested. So let's go and find the first person projectile. So it's not an easy way, but if you go back to the map it shows the content browser. Go to first person BP. BP stands for blueprint. This is auto generated from the template. You click into it and you can go to blueprint, and you see there's a blueprint called first person projectile, which
back in the main editor.
Back to the main editor under the content browser. As content, first person BP, and blueprint. I really like this convention, so everything that's blueprint you should put in a folder called BP, and from then on you can know that everything inside here is blueprint. Okay, so once you get there, you can double click it, opens the first person projectile. For you guys, it's probably open the event graph tab. While I was debugging, it jumped to here, so it was in the construction script. Okay, so what are the different tabs? Viewport tab is the actual physical representation of it. So you can see it's a ball, it's a sphere, a yellow sphere. Construction script is basically the constructor. This runs while you're also inside the editor. So it doesn't just work only in game. The construction script allow you to do stuff like when you're editing, you can also highlight debug, visualize debugging and stuff like that. A lot of the time you probably don't have to do stuff with construction script. Event graph is all the stuff that we want to do logic with. This is when the game starts, then the event graph runs. So the difference, construction script run while the editor just running, not even when the game has started. Event graphs only runs when the game's running. On the left side, you kind of see, I haven't talked about this a little bit, but this is the components panel. it just shows that the different components of an actor. So again, an actor, this is not inherited from an actor. So maybe it's not an arrow, it's not a good spell, but like it's contained. This thing is like contain a bunch of components. Yeah, something like that. So in theory, you can have an actor that's empty, that doesn't have any mesh, doesn't have to do anything. All he does is does logic. It doesn't have like a geometry in the scene. But this thing has a sphere and has a projectile component. Okay, so we go to the blueprint, and we see that there is an event head right here. So this event head is, they have a crazy good comment here too. When the actor bumps into a blocking object, or blocks another actor that bumps into it, so this is where it hits something. They will do add physics impulse when physics object will hit. So in the game, when we play, we shoot at this cube gets knocked over. That's when this code is running at the impulse into any physics object that we hit. Yeah.
That's execution, like the program counter. Remember?
Execution, yeah. Blue is either component or actor. Yellow is vector. Red is Boolean. Deep blue, like dark blue, is struct type. And I think this is name, whatever. Anyway, each of the component, each of the type has a color. Okay, so are you in the first person projectile? Oh, so did you double click on here when you were outside the map? Sorry, are you here? Okay, cool. Yeah, event hit. Okay, so I actually don't really care about if I knock something up because I just want to teleport to a position, so I don't really care about knocking. I can just alt click on this link and then break it. So when an event hit, I don't actually really care about this stuff. Actually, you can just delete this for now, because our goal is just to teleport. We don't really care about knocking something.
So, you just press delete?
Yeah, just press delete. You just group, yeah, like
On a Mac,
drag.
I think it's function backspace. I don't know if the...
It's just
Yeah, delete. And you see how the compile button changed. So it means that it's dirty now. It needs to recompile. So basically, it's really just compiling code again. So
This is, real quick, remember what you showed me last week? 4.15. Krishna, you asked in class, like, can you see what blueprints get compiled into? So the next version of Unreal, this is 4.14. 4.15 is shipping with production-ready blueprint to C++ compilation for you. So you can actually see what this turns into.
oh yeah, they're shipping it now.
Yeah.
But we're not doing it, so don't worry.
Yeah, it's not out yet.
Yeah, so you have to compile, and then once you compile, when you play, when you shoot something, it doesn't get knocked over because that logic is gone. And you shoot like crazy. Okay, so we're gonna add a logic. So our idea is we hit something, we're gonna teleport the character over. So, okay, so let's look at what event hit returns. So it has my component. So it's a which of my component. So my actor has a bunch of components. My components hit. This is the actor that I hit it with. So the other actor that I collide with. And then the component of that actor that I collide with. So if I collide with a character that has arms and stuff like that, it will return here another person, and then component will return like the left arm for some example. So for here we're gonna do like a branch. See. Let's just hit, yeah.
So if Trung right clicks or if he drags an arrow off, it'll prompt you. This is like your this is worth, I guess, mentioning. This is like autocomplete in code. So
Yeah.
this is everything that you could call given whatever you just dragged as an input.
Yeah.
And it's if you do it again, it's like filtered by.
So you can do right click, or yeah, it's like context sensitive.
Yeah,
Click
so
on
it'll
it.
intelligently like pick methods and functions and data that you can get.
So these are only available nodes that you have. Like let's say for math, you can do like and boolean and stuff like that. So this is like all the nodes you can do. So if you want to find something like you want to do an add, you can do a plus, and then it's kind of go to like all the possible addition operation it can do. Actually, before we go to the create new event, I'm gonna actually from hit result, if you drag it out, it will show an option called for break the hit result. What it does is just construct the hit result into like a bunch of it's a struct, right? So this is all the property inside a hit result. So whenever something hits, show you all the different parameters of the hit result.
So if you
Click on the hit, drag it out.
if you just click break hit result.
Okay, I'm gonna hit break result. If you click on this, it automatically pops out a new node for you.
So for those who don't have C++ experience, or has anyone not ever touched C? And don't be afraid. Like there's no judgment if you haven't. Okay, one person. Or you've touched C++. So a struct is just like a union of like mathematical union of data. So it says like.
So you can have a struct. This is how you declare a struct in C. You can have like int x, int y. So it's very much like a class. Except that it's all public and it usually doesn't have any functions associated. It's just a collection of data.
So since C is not object oriented, this was the way you would make objects.
Yeah.
Like that.
Yeah. So and everything is public. So basically this struct hit contain a bunch of stuff right here. Okay. So we want to, when we hit something, we're just going to set a character over there. So there's another node. If you right click anywhere and type in get player character, type in get player characters, this returns to us the actor, which is a character. It's always available in everywhere. Yeah. Oh no, we in a blueprint called first person projectile. So we are the bullet.
We have no reference to the player.
Yeah, we are the bullet. We are not the player. So the first person character, the actor is the player. So basically the actor is like the disk pointer, essentially. So so we are the bullet right now. So we don't really know where the player is. So the player is the special object that's always available everywhere. So any other blueprint can access the characters. Usually you can't really, like let's say I want to access another bullet, usually it's not available. You have to pass it in as some sort of variable as input. But the player is always available. So, okay, so we make a player and then you drag the return value from the player out. You can type in set actor location. If you type in set actor location, there should be a node called set actor location. Basically a function that says exactly where the actor should be. Okay, so where is the actor should be?
Aha!
So why do you want to, why don't you just want to straight from hit location from your
Because hit is a structure.
Well, you could. It's the same thing.
Actually, it's the same thing. Honestly, I just want to point. I guess I just want to show you guys the how the entire struct looks like. Yeah, but in theory, you can just go from hit location over.
Yeah. So the idea behind like them condensing hit into a struct is because those are the 6 most commonly used things, and if you need full power, you can go to it.
Yeah, this is the full power. So this is basically all these set variable over here. pack over here. I wanted to show you guys that you can, from some variable, you can break it out into a struct. So if a variable has a struct type, it's a structure, you can always drag it out and break it out so you can see what's inside the return value. Yeah.
So something that was always confusing for me, I don't know if this was for you, but sweep and teleport, like, what the hell is sweep and teleport? So what I always did, the first way I learned this was if you hover over teleport on the right and get set actor location. So if you hover over teleport with the mouse, it'll give you a tooltip that'll say like, should this carry the physical properties of motion where it was before? So like, does it maintain momentum and stuff like that? Those things always confuse me, and if you don't know what a blueprint's like input does, and it's made by Epic and not by you, odds are they put a really good comment in. It's like this stuff is really useful, and if you're ever curious about like what something means, hovering over it is usually enough to tell you what it is.
Yeah. For our purposes, yeah. So this case, you almost don't need to use this.
Yeah,
for
no,
this
there's no
case,
need to. Same thing with sweep. Sweep just says like, do I want to check for collisions at the location where I'm moving?
Okay. So what else am I missing?
Yeah, who can say why this won't work? Yes.
Yeah, you need to flow from event hit to set actor location. And then, oh, sorry. I can't zoom out. There we go. You need to compile it first.
This doesn't check that.
It doesn't say check yet. Yeah. But let's see if this works first, though, before we get to the floor.
You have a save there. I think it's because you have two editors open.
Stop sewing. Oh
Wait,
no.
Just say cancel. No, just hit the.
Oh, I have.
You have another instance open. Yeah, so close that one.
What?
Yeah, I asked you at the beginning. You open two.
Okay.
Did you guys have the same thing? Yeah. Oh. Whoa.
Okay.
Why does this not work?
What? No, it's
no,
working.
I know, but why is it like
Lagging. Yeah, I'm not really sure why it's lagging.
So, yeah, exactly. So what happens when the bullet hits something and hits something again?
Because the ball
It's bouncing.
The ball is still moving.
So what else do we need to do? We need to probably destroy the ball.
Yeah,
Right.
Who needs the ball after it hits something, right?
So if you drag from asset location, you just call destroy.
Bye bye. And note that takes self. Self is this.
Self is you can destroy any other actor, but self is just destroy itself.
Yeah, don't put other people out there. It's not fun.
Yeah, just destroy actor. So it will just destroy itself. So when you hit something, now you teleport to that location.
So
Okay.
this is how to make Portal in 10 minutes. No,
Yeah.
kidding.
Well, because we have to go through a lot of stuff. But are you guys all on the same page?
Destroy actor.
Destroy actor.
So destroy component would destroy one of the actor's components. Which is not
Yeah. And you want to destroy the entire thing.
Also, so I did make a note of saying on Thursday that when we were talking about memory management and destroy and spawn, I said that I erred in saying that Unreal is reference counted. Okay, let me just clarify. Unreal is reference counted for those of you who are interested in this, but it is also garbage collected. So I said it wasn't garbage collected, but it is. So that's just something to know.
Yeah.
If you're curious about that, come talk to me after.
Okay. So, but now we teleport. Even we hit like the wall and stuff like that, it's kind of silly. So we don't want to do that. We want to make it. We only hit the floor that it works. It teleports. So let's go back to the map and then select our floor. Or you can find in the world outliner there's supposed to be a floor object too. By the way, these names can be changed to anything like my floor, or your floor, or something like that if you want. I don't know. It doesn't matter. It helps a lot when you have a big scene and you want to find things. So anyway.
If we open up your game and you name things floor 1, 2, 3, 4, 5, 6, 7, 8, it's going to be really hard to keep up. So.
Well, I mean, they have wall 1, 2, 3, 4.
I know, but
But anyway, yeah, the folder helps you organize. Folder doesn't do anything, just to help you to structure the outliner. Okay, so if you go to the floor, and I'm gonna zoom in a little bit here. So in the inspector, in the details panel, I guess the details panel down below, you can go to here, and then if you scroll through this down below, eventually you get to one that called actor. And then sometimes they hide stuff. So when you go to the actor tab and you click on show advanced, it's gonna show more stuff down here. And there's something called tags. I'm just gonna add a tag called floor, or maybe teleportable.
Teleportable.
Teleportable. You can name it however you want. So you can add a new tag. So the idea here is you add a new tag, and then we're gonna check wherever we collide with something, we're gonna check if it contains that tag. So let's go back to the first projectiles. Okay, so we want to do that when the event hits fire. We're going to check whether it's the floor or not. So if you go drag from execute again, and then type in branch, this is exactly an if statement is the same thing. It's just called branch in Unreal. You type that in, it's automatically kind of like insert in the middle. If not, you can just connect the dot. So, okay. So what we want to do is we want to find condition whether we actually hit the character. So you see, so on the event hit, it returns an active reference. We're gonna drag it out and call get tag and type in get tags.
So who can notice something different about the data type next to tags? Like, see, there's a little, the icon doesn't look the same as every other icon. Yes.
Yeah, it's an array. Yeah, because if we look back at the map, when we do the tag, we add a new, this is an array type, because we just add a new element to it. So an object can have multiple tags, however your game logic wants to be. What dot? Oh, just get tag. Yeah. A lot of time, what was the most intuitive search term you can come up with is usually the first thing. Yeah. So you can get tag out. Let me deal with this thing. Okay. So tag return an array. So this part is a little bit annoying, but we have to do, so drag out from event hit again, and type in for each. Oh, does this contain? Contains item. Oh, awesome.
That's a new one. I didn't know about that either.
Okay, so you drag out from tag, contains, and then you can just type in is contain teleportable, or whatever the tag name that you have. Okay.
Up to you.
Yeah. So this is one way to do it. The other way to do it is Unreal also has something called like for loop. So each time for loop, you can like loop through it and stuff like that. Like it basically do a for loop node kind of stuff. But I think the contain is more efficient in this case, just cleaner. So if it contains teleportable, if it's true, we're gonna set after location. So let's see if this works. So you see now if I hit the, I only teleport whenever the thing bounces on the ground.
That's a good point. So that you'll notice that contains node doesn't take in execution.
Yeah.
So there are certain things like these are
Everything that is a read operation.
Yeah. So anything that's a read memory operation, you don't need. It's like because it could be done via a macro, right? So like there's no. What's a good way to say? So this if statement is a branch, right? The branch is an if statement. You can imagine this contains thing as the expression that you'd put in if parenthesis this. So that's why it doesn't need its own execution.
Yeah.
Alt click on the line.
How do you break the other into the target thing again? Like the target when you like that to be array.
Oh, for like so if you get tag, it's automatically give you an array.
So
yeah,
anything that looks like that looks like takes input as an object and output as another object is a getter. So it's just like get local variable and tags.
Yeah. Contain and basically contain just takes in another reference. So you, in theory, you can check other type or check other names also. Yeah. Okay. Okay. So now we have basically makes more sense of the game. Okay. Cool. So you see that it's firing like actually really fast right now. So so the next thing I guess is I want to constrain this a little bit so that you can't just like shoot like crazy like this. It's just like yeah. So I want to constrain that you can only fire every 1 second only. So that's just changed the fire rate. So if we go back to the first person character blueprint, so what we're gonna do now is we're gonna put a constraint that you can only fire after 1 second has passed from the previous fire. So the input fire here, basically kind of like similar to code, I can create a new variable in the blueprint. So let's go back to the first person character blueprint. We can create a new variable called can fire. So B stands for Boolean. That's my convention. And then the type, when you create a new variable, it's gonna default to whatever the previous thing that you have. But if you click on the variable B can fire, you can see the variable type on the other side on the details panel. So right now it's a Boolean. So this is basically a member variable of this object. Very similar to just like a class, has a bunch of variables. It also has macros, also has functions, so you can think about it as like writing code. So B can fire the default value, say please compile the blueprint. So I'm gonna compile. So now I can put a default value here. And if you check it, it's mean initially we can fire stuff. So what we want to do is we want to create a timer. Actually, so before we get to the timer, I'm gonna say after I finish firing in the end, you can drag it out and type in set B can fire. Oh, where is it? Yeah, set can fire.
So you'll note that if Trung is following the epic syntax for naming things, which is like prepend with the, so like B boolean, F float, B vector, it'll automatically like truncate that for you.
Yeah, it turned into like can fire.
So
That's nice, pretty.
Yeah.
So basically, after I finish fire, I'm just gonna set can fire to false for now. Yeah, so that means like right now I can only fire once. Well, not yet, but false. Sorry, false. I don't check it. It's false. So over here, what would be a similar thing I could do here? So before I fire, what should I do? Yeah. So what is the node that you would use? Branch. Okay. So drag it out. Type in branch. You can type in branch, and now it's okay if it's not linked over here. This is actually a complete separate flow, so don't worry about it. This is for like a touch device. Okay, so branch out, and then you can just drag from your beacon fire over here, and just put over here. If you drag over, it will just automatically hook it up to condition. So if can fire is true, then I can fire. Right. So in this scenario, not simulation, where I play, I can fire once, and that's it. Okay, so now I need to reset the can fire after 1 second. So there is something called, if you drag from the true, called, if you type in timer, there's a bunch of stuff over here. If you type in timer, so I'm going to use something called set timer by event. This create a new timer for us, and then I just give it 1 second. Wait, is this time is in seconds? Yeah, so time 1 second. So I will wait 1 second, and it's non-looping. So I'm just doing it once, and it takes in an event. So event is not a function event. How should I describe
It's
event?
like same way a lot of languages have a like delegate or messaging system. Like an event is just saying like when this object receives this signature, call this function or
Kind of
do this thing.
Yeah, kind of like a callback or something.
Yeah, it's like a callback.
Yeah. So so it needs to take in an event. So we're gonna create our own custom event. So again, you can type in custom event, and this is gonna be our event. So our event would be make it clear timer. Okay, so make it can fire. So like so clear can fire. And the event acts just like a function, so it takes in the execution flow. So the event can, if you drag out, you can do set can fire bad to true.
So you'll note that Trung also moved the red box off the edge of this event. That's like a reference to the event. So it's saying to this timer, trigger this event when the timer expires.
You can use either way. Yeah.
For the timer? Well, okay, events versus functions in general, this is a little bit advanced, but events can be replicated, so events can process over the network. If you've heard of like XML RPC or any kind of way of, basically events give you a way for one computer to tell another computer to do the same thing at the same time. So functions can't be replicated, which means the actions can't be processed across all members of a network game, but events can. Yeah, that's a good way of thinking about it.
My original reason is because I want to show you guys what events look like.
Well, yeah, but events are also events are also way less expensive. So it doesn't like functions will pop a new like stack, right? It'll do a local variable stack, and events don't do that.
Yeah.
Yeah.
Okay, so we have an event. So after 1 second, we clear and we make the can fire equals true. So let's see if that works now. Compile. Make sure you save. Save and compile is not the same, by the way.
Be wary of what you save.
When you save, it doesn't compile, doesn't save, so make sure you do both. So now I can't fire like crazy, but there's like a 1 second delay for my teleportation. So that's awesome. Yeah. So I'm just gonna wrap up right now. In case I show some time, but so you can think of either doing an event. Another way you can clear the can fire is you clear it when the bullet has hit a floor, then you actually reset the can fire event again. So if you want to do something that you already have your character, let's say you want to clear it when you hit the ground, you get the character, and you have to do something funny, which is like a cast. You have to cast as to the character type that you have. So get player character, get you a base character, but you can cast it to the first person character. Because why do I cast to it? Because the first person character is the one that has a variable called can fire. Yeah. So if I cast it over a person's character, this is inside the bullet projectile. If you want to access a variable of another object inside that blueprint, you need to cast it to the correct type. So get player characters, return only a character type. But what we're doing is we're doing a blueprint called first person character type, which is inherited from character. That's why I need to cast it over.
Also, something cool about these casts is this cast node, you'll note, actually will tell you when the cast fails. So you won't like equivalent of segfault if you like cast something and it's wrong. So this uses the C++ static _ cast convention, which will actually like forcibly fail if it's not what you're expecting to. So it's really good for like your game won't crash all the time and you won't know. Like, it's really good when it does that.
So if I do something like that, then I can clear set fire like this. So basically, what I did was instead of using a timer, it will clear fire when I hit the ground. So it's not very so I can shoot multiple times because it clears so fast. Because it clears every time I hit the ground. So maybe that's not the best metric that's condition you want to use, but they give you a couple of different ideas. So you can think about making a game where you have to sneak into a giant tower or something like that, and you have only certain platform that had the tag teleportable, so you can only jump and teleport to different places. So you can strategically place around, and maybe build a castle. There's a lot of cool stuff you can do. So hopefully this helped to tie up with your next homework assignment.
which is what we're about to go into right now. So, thank you for the kind introduction, Trung. Also, just kind of wanted to note right now, express not only my gratitude to you guys for listening, but for Trung for taking time out of his days to do this, because it's not every day that we can take a course from someone who's actually worked at the company that makes the software. So he has a lot of insights, stuff that I wouldn't know, stuff that a normal Unreal developer wouldn't know. So thank you, Trung. Okay, so you guys have a lot of work coming. Can everybody read this? Is this big enough? Yes? Okay. So, what you're going to be doing over the next 3 to 4 weeks is building a arrow-based VR teleportation first-person shooter. That's a mouthful. So we're going to dig into what that means. I guess first thing to note here is you're going to be working in teams of 4. I think there will be one team of 5. So you're not going to be attacking this solo. There's going to be other people to work with so that when you hit bugs and stuff in Unreal that you're not sure how to solve, there are people around you. I do, however, really want to stress, don't wait a week to start on this. You'll see that there's a deadline that will make that impossible, but don't wait a week. So let's just go through briefly what we're going to be asking you to do. I'm not going to go through all this detail, but I will post this by 3 o'clock today. As soon as I get back to my computer, I'll put it on the website. But without further ado, so your character should be able to hold a bow with one hand and pull back an arrow with the other. Release the arrow, it shoots, same way normal archery works. So I should also note that you guys are going to be using the HTC Vive for this, which means you're going to get full hand controllers, really expensive, awesome hardware, and I'll show you. We'll do some introductions to that on Thursday, but access to that will be limited. We only have 5 of them, I believe, and those are going to be shared between this class and the other game design section, which means that one team will have access to one Vive for the majority of the time of this project, but if there's only one Vive, right, you guys can't always be developing on that. So what's really important about this arrow shooting is that you work to prototype things. You need to be able to test this without having the Vive controllers around. So what we're going to do in lieu of that is give you guys Xbox controllers and let you use the triggers, and you can map the buttons to do the same things. But I really want to stress that you want to test this as much as possible before you get access to the headset and not have to rely on that to determine whether your stuff works. So that's why there's a lot of stuff on prototyping there. So once you're done with the prototyping, I suggest you move on to the VR implementation. The next thing is teleporting. We talked about that today. Trung gave a fantastic demo on basically everything you need to know about how to do that. The trick here is that your player is going to be shooting arrows instead of a gun, right? So the player should be able to toggle something that says I'm shooting a damage arrow, which will hurt other people, versus an arrow that will teleport me somewhere. So same thing in Portal. You have guns that do different things, whatever. Consider though that when we were teleporting in this game, if you had a headset on and you did that, you'd be in bad shape in 5 seconds. So you really need to come up with a way to smooth those transitions. We'll talk more about that later in camera effects that you can use to do that. The canonical way of thinking about that is you want to make the screen go slightly dark or fade to black and then unfade back into whatever you're moving into so that it's smoother on the user. Yes, simulate a blink, exactly. So that's something to consider there. Game mechanics. So we've given you brief, broad directions here. You're a player, you can pull an arrow, you can shoot an arrow, and you can teleport somewhere. Right? There's a lot of things that I want to leave, that the staff and I want to leave up to you guys to determine. Right? This is uncharted territory. This isn't a class in games, but this is a game that we're asking you to make. The trick here is that we want you to figure out what kind of mechanics you can design around the whole VR component, so that this isn't your normal shoot 'em up game. Right? It's totally up to you. How you implement those mechanics and what you choose to do to make this fun is 100% at your discretion. So you can think about having player attributes, so maybe they get hit with an arrow and they slow down, or they can't teleport for 5 seconds, right? You can be pretty creative here. This is where it gets tricky. Not only is one person going to be able to shoot an arrow, but you're going to be able to have 2 people wearing HTC Vives shooting each other with arrows. This may seem super daunting, and it is and should be super daunting, but we're going to have at least one lecture fully dedicated to exactly how to make multiplayer work. And Unreal provides all of the tools that you need. You will have to write none of your own code. You just need to know exactly how to use them, and that's what Trung and I will teach you. So we did this for pen apps the past 2 times. It works. It's definitely doable. But there's a lot of like gotcha, I forgot this things that are going to be coming in handy. So you won't have to change the way you develop your project, but that's why I thought it was nice to get into like network player start at the beginning, right? You need to have somewhere to spawn your opponent if they get into your game. Stuff like that. So we will be asking you guys to make this network. Yeah, so again, prototyping here, like you should be able to play the game fully without the headset. So when you're using like an Xbox controller or even mouse and keyboard, like there should like P could like teleport you somewhere, right? Just come up with any way possible to test that doesn't rely on the hardware. And yeah, so players should receive visual or haptic feedback when there is a game state change. So if like you get shot with an arrow, like there should be some feedback to the user. This is kind of on the mechanics stuff that we're leaving up to you, but we just wanted to put these out as basic guidelines, right? So there are certain things that we take for granted in first-person like games on the computer, right? So in VR, stuff can happen behind you, and you'll have no idea what's going on because there's no like map of the world that you can just see. So there needs to be some way to indicate to a player that something has happened to them that may be outside their field of view. So consider that. And lastly, be creative. This is going to be a bear and it's going to be a lot of work, but we also hope that it's a lot of fun. So just, yeah, keep that in mind. So we're going to provide each team with a Vive. You guys can all keep your Oculuses, which means that you'll be able to test the HMD integration, like head rotation and like moving around the level without the Vive. The only thing you won't be able to mimic with the Oculus is the controllers, which is why we're going to give you an Xbox controller. So keep that in mind. Yes?
Then could it be like Oculus Rift and Xbox controller be like going together to like simulate work?
Exactly. That's the idea. So, but you can't do the whole like pull an arrow back, right? Yeah. So you can find a way to like mimic that as best as possible. Here's where it gets interesting. So in order to avoid what happened with this project where people didn't seem to start until a week before, we are implementing some deadlines and deliverables. So this is Thursday. This is 2 days from now. So 2 days from now, find a team, and this doesn't have to be like 10 pages long. It can literally be a page. Shouldn't take very long. Break down what you think is going to be the hardest part of each of these tasks, who's going to do each task, and like just basic, like I'm not looking for anything crazy here. Like you don't have to do a Gantt chart, just like, try to plan out your work and divide the labor between which team members find things interesting. We will give you feedback like within a day of this coming in. So on Thursday, you guys should have feedback by Friday as to whether we think your work division is fair, because there are some things that we will know will take longer that you guys may not know. So don't think we're going to leave you hanging with like, if I say, okay, I'm working with Trung and Trung does everything and I'll make a menu, like that won't be okay. So we'll keep an eye out for that. So February, so the 16th, I believe that's what I said, is the alpha demo. So a game alpha is generally something that's playable. So you should at least be able to, demo the fact that you can be in the game. This doesn't necessarily have to include multiplayer, but you should have like the concept of pulling back an arrow and letting it go mastered by then. 21st is going to be the beta mechanic, so that's like a week later. You will again, this is a little bit different. So the beta mechanic demo is where you guys will actually be playing each other's games in class and finding out like cross-pollinating as to what was hard, what went wrong, what went right. This is when you want to have as much done as possible before this so that like you can fully maximize that day. Like if your game doesn't work and you come to the beta demo and no one can play it, it's going to be a useless demo. So try to avoid that. And finally, the final is the 28th. So I believe, so that's the week before spring break. And we'll have final demos in class that day. Also, if you refer to the schedule, class that Thursday is canceled because Trung and I will hopefully be at GDC and not be here. So just keep that in mind. As far as the submissions, same thing as last time with the README. Just, unfortunately, you can't demo this game in a web browser, so the only thing to note is by the final demo, like make a YouTube video of someone playing. Doesn't have to be fancy. Like, you don't have to go full like Hollywood trailer. Just get some gameplay footage so that someone can at least see what you did without having the $1,000 of hardware. Also good for your own sakes, because it's good to have this to show off. It's always good for your own personal reels or whatever, but B, this is also a cool time to kind of talk about something that I've been working on for the past couple of months that we're hopefully going to get put together. So I'm working with some friends over in Wharton who are MBAs who are like super interested in the business side of VR and like basically see like huge money and no good stuff yet. So that's what their interest is. Our interest is making stuff. So we're going to try to set up a VR like day in engineering where there's 3 hours of guest lectures, hopefully from Magic Leap, maybe Oculus, and then like cocktail hour, you guys meet everyone, talk, whatever. And then also showing student demos. So if this happens by the end of the semester, which it likely should happen after spring break, hopefully you guys from this class will be able to show off your stuff in front of all these like venture capitalists, MBAs, whatever. So good to have this stuff done by then. Hopefully you guys are all interested in that. But yeah, just additional incentive. So last thing before we go today, just a couple words of advice. There are things that we take for granted when we play games or when you have experiences in VR that oftentimes you may forget about when you're developing. So it's always important to play what's out there as much as possible. So come to the lab, like hop on the machine, like I'll install Steam for you, we'll give you whatever games you want. Just, play it, have some fun, see what's out there. Yeah, so we already talked about this merging thing. Don't try to merge blueprints. Like work on separate blueprints and then use Git to merge your changes in different parts of the project later. If you try to merge changes to the same thing, you're going to blow it up oftentimes, so don't do that. Also, this one above is a little bit important. So we used Unreal for a pretty good while today and it didn't crash, which is good. That doesn't always happen. So save your work as much as possible and note that saving this doesn't save this. So there's buttons like File, Save All. It's useful. So just beware of what you save and what you don't. You can have the editor open and like if I try to close this right now, it'll tell me that I have unsaved stuff. So if you've committed to Git and you haven't saved these things, other people on Git won't have your changes because they weren't saved before they were committed. So just make sure you save before you commit, otherwise you'll run into merge headaches. And lastly, please come to office hours. 3JS stuff is nice because you can work on your laptop on your own. Odds are you guys are going to be needing to use the big machines to do this stuff because it's very compute intensive, and as you've seen, your batteries will die in 20 minutes, right? This stuff happens. We're always going to be in the labs. Hopefully all of your keycards should work. As far as I've heard, yes, Santi, keycard works. Yes, very good. Your card should work, so we'll always be in the lab and willing to help you. Feel free to ask us whenever you want. With that, I have 2 minutes left, so does anyone have any questions in public that they want to talk about with everyone here, concerns? Okay, so last thing before you all leave, this is again the first one of the class. I hope you guys all enjoyed the first project. The second project is much more ambitious, and we're going to do everything we can to make it as much about learning for you guys and less about dealing with pipeline-y junk. So let us know what we can do to help. If everyone is having a hard time, we'll think about scaling back and doing that, but I prefer not to because this is really important for you guys to learn and you're going to get some good work out of it. So thanks, and have a great rest of your Tuesday.